In this video, we're going to take a look at the application of operations with polynomials. With each of these word problems, we're going to take a look at how we can use addition, subtraction, and multiplication of our polynomials to solve for our answers. In this first word problem, we have a rectangular garden with one side with a length of x plus 7 and another with a length of 2x plus 3. Before I take a look at part A and part B, I'm first going to draw a picture of my garden. Now, none of this is, of course, drawn to scale, but I'm going to have a length of x plus 7 and the second with a length of 2x plus 3. Now, part A says, find the perimeter of our garden in terms of x. So for perimeter, we need to know our perimeter formula, which is the sum of the sides, or more specifically for a rectangle, will be 2 times the length plus the width. So from here, I can substitute in my two values here, my length and my width. So I have 2 times my length, which I could say is x plus 7, plus my width, which is 2x plus 3. Now from here, I will be adding my polynomials. I'll be combining my like terms of my x and 2x and my constants 7 and 3. So I get my perimeter is equal to 2 times 3x plus 10. Now I'm not quite done yet because I can distribute my 2 through my binomial and get a final solution of my perimeter is equal to 6x plus 20. Now, because this is going to be a perimeter, I can just label it as units if I wanted to. Now, part B asks us to find the area of our garden. So for area, we need to remember our area formula is A equals length times width. So when I substitute in my length and my width here, I get that area is equal to 2x plus 3 times x plus 7. Now I can use either method here, either double distributing or my grid. To solve this, I'm going to go through and double distribute here, and I'll show that I get 2x times x is going to be a 2x squared. 2x times 7 is going to be plus 14x. And then I can go down to distribute my 3 through as well. So I get a 3 times x is going to be plus 3x. And a 3 times 7 is going to be plus 21. From here, I always look to combine my like terms. So I have my 14x and my 3x as my like terms. So I can get that my final area written in standard form is going to be 2x squared plus 17x plus 21. I could also add on units squared to show that this is an area. In our next problem, we have a triangle, and our triangle has 3 given sides. So I'm going to start by drawing my triangle out. Nothing's drawn to scale. And we can see that my side lengths are going to be 3x times x plus 1, x squared plus 5, and a negative x squared plus 7x. This problem is asking us to find the perimeter of the triangle in terms of x. So the perimeter formula for our triangle is just going to be P is equal to side 1 plus side 2 plus side 3. So I can substitute in each of my sides and get the perimeter is equal to 3x times x plus 1 plus x squared plus 5 plus a negative x squared plus 7x. Now before I can go through and drop my parentheses and add those last two terms, I need to first distribute through this 3x to my first binomial. So both the x and the 1 will get a 3x. So I get 3x squared plus 3x. From here, because there's nothing else to distribute here, just the plus 1 there, I can drop my parentheses and rewrite my polynomial expression to continue as plus x squared plus 5 minus x squared plus 7x. Now be careful here with this x squared. You can see how I wrote that as a minus x squared because it was plus a negative x squared. From here, I want to take a look at combining my like terms. So the first thing I'll do is look for my x squareds. So I have a 3x squared, a positive x squared, and a negative x squared. Now I can look to combine my x's. So I have a plus 3x and a plus 7x. And lastly, I have a 5 by itself. So when I combine these to find my perimeter, I'm going to combine my 3 purple boxes. So I have a 3x squared plus x squared minus x squared leaves me with 3x squared. Then if I look at my x's, my x terms, I have a 3x and a 7x. They're both positive, so I can combine those to get plus 10x. And then the 5 is by itself, plus 5 units. So this would be my final solution for the perimeter of my given triangle. In example 3, we have a cylinder, and we are given a height of 7 and a radius of t minus 2. Now this one's a little bit tricky because we want to find the volume of the cylinder. So if we think of a cylinder like this, here's our cylinder I can draw in, then we are going to have a height be equal to 7, and its radius is equal to t minus 2. Now the tricky part here comes in with our formula. Our formula for the volume of a cylinder is pi r squared h, and it asks us to find our answer in terms of x and pi. So when I go through to do my substitutions here, I get that the volume is equal to pi times my radius squared. Well, in this case, my radius is equal to t minus 2 squared times my height, which is 7. So I've just gone through and done all of those substitutions. I'm going to kind of do a little sidebar here on this t minus 2. When you have a binomial written like that as a binomial squared, t minus 2 squared, with that is the same thing as writing it as a t minus 2 times t minus 2. Now we're going to discuss this a lot later. But we know how to multiply this already, so we're going to go ahead and do that. So if I double distribute, I'm going to get a t times a t, which is equal to t squared. I get a t times a negative 2, which is going to be a negative 2t. And then when I distribute my negative 2, I get negative 2 times t, which is negative 2t. And negative 2 times negative 2, which is plus 4. When I combine these terms together, my like terms end up being my middle ones here, my 2t, negative 2t and negative 2t. I get t squared minus 4t plus 4. So I can rewrite that back up into my problem. And when I do this, I'm also going to do a little bit of rearranging and write this as v is equal to 7 pi times the quantity of t squared minus 4t plus 4. Now, this would be one way to leave the problem. We also could distribute through that 7 pi and get our final volume is equal to 7 pi t squared minus 28 pi t plus 28 pi units cubed, this time for volume. Now you can notice here that our answer has both t's and pi's in it, and that's what it means when it says leave in terms of x and pi, or if we put everything, I guess it should say t's and pi, since we use t's there. I'll make a quick change there. Everything's left with the variables of t's and pi. Now in our final question, this is a little bit more complex question. There's a lot of reading to go on here. So we're just going to take it sentence by sentence and see what we got. So it says, Allie has a garden that is the shape of a rectangle. So I can go ahead and draw that garden, shape of a rectangle. And it says that its length is twice its width. So if I said that the width was equal to x, that would mean that my length would have to be twice that, and I would represent that as a 2x, because twice means to multiply by 2. So I can label that in my picture as well now. So he decides to make a new garden that is 2 feet longer and 2 feet wider than his old garden. So if I'm going to add on 2 feet, I could say I'm going to add on 2 feet here, making my width 2 feet longer, and then add 2 feet onto my length, making that longer. What I now have is a garden where this full side is going to be equal to my original 2x plus this little piece of 2 right here. So I just write plus 2. And if I wanted to find the measurement of my new width here, I would say, well, this started off as x, but then I added 2 to that. So now I have a new width that's equal to x plus 2. So my original width was x, my original length was 2x, and then from here it says, which expression represents the difference between the area of the new garden and the area of the original garden? So right away I'm seeing some key terms here that deal with the area, and we are doing our new garden versus our original garden, and it's asking for the difference between those two, which to me means subtraction. So if we start off here, I'm going to start finding the area of my original yellow garden here. So the area, we'll call it area of O, area of the original, is equal to the length times the width. Well, in this case, the area of our original is the length of 2x times x, which is equal to 2x squared. Now, if I wanted to find the area of my new garden, that's going to be a little bit different here, because now I have to use my new values that I have in red. So my length now is going to be 2x plus 2, and my width will be x plus 2. Now from here, I'm multiplying two binomials, so I need to remember how I do that by using double distributing or setting up my chart. If I was to set up my chart for this, I can draw my tic-tac-toe board, plug in my values of 2x plus 2 and x plus 2. From here, I remember that I'm going to multiply. So when I find my products, I'm saying 2x times x is a 2x squared. 2x times 2 is 4x. 2 times x is 2x, and 2 times 2 is 4. Of course, I remember I can combine my like terms along my diagonal to get 6x. That gives me a new area is equal to 2x squared plus 6x plus 4. So now I have these two areas. I have my original area of 2x squared and I have my new area. And it wants to know the difference between those two. So when I want to find the difference, that means subtract. So we're going to take our new garden, which is 2x squared plus 6x plus 4. And from that, we have to subtract the area of our original garden, which is minus 2x squared. Now, it's okay to drop these parentheses here from this polynomial because there's nothing to distribute. So I can just go ahead and remove those. And so now I'm just looking to combine my like terms. So I have a 2x squared and a negative 2x squared. Those will cancel each other out. So I get the difference between my two gardens to be 6x plus 4. With each of these problems, make sure that you take the time to read the problem, see what it's asking, figure out what you're looking for. Think about how you add, subtract, and multiply those polynomials. Watch your signs and combine like terms. Good luck!